So hi and welcome everyone to the lecture titled Modulation. In today's lecture, we are going to be talking about a very important concept in communication systems called modulation. So the word modulation, if you just search on Google and write modulation or what's modulation, most of you will be confronted, and pictures like the ones I'm presenting here, you will see that an incoming signals and another carrier signal mixed with each other, and you generate another signal, which is going to be transmitted over the air. But here, I would like to highlight that this definition of modulation that you find in the literature and you find in Google or in some textbooks is very narrow and very limited and very specific. That doesn't generalize the meaning of modulation. So for example, when you look at this picture, it just represents one simple type of modulation schemes called amplitude modulation in the analog form. So imagine as when you see a picture like this and somebody is explaining modulation to you, tells you that modulation is all about one signal is coming and another carrier signal, you mix them or multiply them with each other and you get modulated signal. So this is not the key meaning of modulation. So if this is not the key meaning of the full meaning, the generic meaning of modulation, then what's the meaning of modulation? So modulation, in its simple terms, it means that if you look at Google translation and put the word modulation or look in the dictionary, what alternatives words you will find for modulation, the word modulation. So basically you will find modulation is alternative to modification, alteration, change, variation, revision, amendment, adjustment. These are the keywords that are equivalent to the word modulation. So modulation is a very weird, strange word. We don't use it in our daily life. Do you use it when you talk to your friends or family or teachers? Whenever you use modulation. But imagine when we are confronted with such a word in a textbook, we get confused. It's weird word and out of context. It's just related to a technical term, and that's why when we think about it, we cannot link the relationship between the naming and the method itself. What does it do? So here, if we just understand the word modulation, instead of saying modulation, understand it by the word changing or alteration. Just instead of being confused with the word modulation, can you change it in your mind with the word changing? Modulation simply means changing. Now you will ask me, changing what? I will tell you it's basically the process of changing the properties of a carrier signal. Modulation, the most generic meaning of modulation is making changes to certain properties of a carrier signal. The signal that carries your data or it transmits your data over the air or over a channel or medium or cable. And this carrier signal this definition is very generic, very complete, and very coherent. This carrier signal can be transmitted and received over a medium according to the incoming information via a process called mapping. So what's the definition? The most generic definition of modulation now. Again, changing the properties of a carrier signal according to the incoming information. You have information that's coming and you start changing the properties of this carrier signal according to this. Let's dig deeper a little bit and give you a brief example that can explain this. What's the carrier signal in our case? Let's assume we have a carrier signal called cosine 2 pi of CT. It's a sinusoidal signal. This sinusoidal signal, we like it because it's easy to generate it, and we can change its frequency easily, and it can propagate according to the frequency that you tune to. So when the used carrier signal in a digital communication system is a sinusoidal function, for example, like the one I'm presenting here, then its properties including amplitude, this is the amplitude AC, phase, which is theta, and frequency, which is FC, can be changed. All of them, you can change them according to the incoming information bits, the data bits that you want to modulate, and this will result in what's called amplitude shift keying, phase shift keying, frequency shift keying. So modulation then is just changing. Don't forget the word modulation. When you see the word modulation in anywhere, in a textbook, in a video, in this, link it with the word changing. Changing what? Carrier signal. What? Changing the properties of carrier signals. What are the three properties of a sinusoidal carrier signal? Amplitude. What are the things you can change here? The properties, the variables in a carrier signal. Either it's amplitude, frequency, or phase. These are the only things you can change in a carrier signal. Now, if we choose sinusoidal signal as a carrier, this means that our properties are limited by amplitude, phase, and frequency. But if someone innovative in the future, very intelligent researcher, very intelligent engineer, like you guys in the future, come up with a different carrier, that has different properties, then you will end up inventing new modulation schemes that use different properties to convey and send information. And this is the key. Once you understand the key definition, you become not only understanding the process, but also able to think, innovate, create, and bring new technologies. And you can maybe patent it and go for manufacturing products that can be sold to companies. So now, let's give an example to understand this better. Let's assume we have an information sequence. Let's assume you type a message, a WhatsApp message, you want to talk to your friend, and this WhatsApp message, the first word of it, let's say W. When you convert W to ASCII code and then low-level language, at the end, when it reaches the processor, it should be zeros and ones. So let's assume that the sequence that represents W is 1010. This is the sequence of bit 1010. And this sequence can be converted to an electrical signal, which if 1 comes, you can say give it 5 volt. If 0 comes, keep it 0 volt or 1 volt, whatever. You just create a signal and suppress a signal according to the incoming information. Then you have an information signal in a form of an electrical signal that represents 1010. You look at the right-hand side at the bottom of this slide. So this is your information signal, your coming information signal, and your carrier signal is, let's say, cosine. This is cosine signal that has certain specific frequency. All what you need now, based on the definition of modulation, is to change this carrier signal according to the incoming information. What properties we can change in this carrier so that we can convey the information? First, we can change the amplitude. If 1 comes, if the information is 1, let the carrier amplitude to be the same. So the amplitude, the carrier remains the same. If 0 comes, then suppress it. Make it 0 almost, the amplitude. If 1 comes, don't make any changes to the amplitude of the carrier, which means it's appearing the carrier amplitude. If 0 comes, then just suppress the carrier. Then this is amplitude shift keying modulation scheme. We call the modulated signal here amplitude shift keying. Now, this is one way of modulating, means conveying our information by changing some properties in the carrier signal. What other possible ways we can send our information? By changing the frequency. We can I told you there is a mapping process during the modulation. We can say that if 1 comes, then the frequency is gonna be, let's say, 900 megahertz. If 0 comes, then the frequency, let's make it 200 megahertz. And you continue according to this rule until you send your whole message. This is frequency shift keying. Phase shift keying, you change the phase as the name implies. You change the phase of the carrier according to the information. If 1 comes, don't make any change to the phase of the carrier. It remains the same. However, if 0 comes, then flip the phase and change the phase to pi instead of 0. Here the phase will be pi, and continue until the cycle of the 1 finishes. And you continue like this. So now it's clear to us what modulation is. Modulation, again, is changing the carrier properties, which is the amplitude or phase or frequency, according to the sequence of information bits that you want to send. That's it. Now, why do I need a carrier? This is what we need to answer here. Why do we need modulation? Cannot we just send our data immediately through the air or through a channel? Yes? If you are speaking now, and you want to talk to somebody who's far away from you, cannot you just send your voice and scream at him, talking to him? One might say, okay, but if you do this at a certain distance, your voice will cut and you will not be your friend will not be able to hear you. Yes, he will not be able to hear you because your voice power has certain range, certain limit. You cannot exceed it. And the other problem, if many people want to talk with each other and all of them are shouting, they will be interfering with each other. Now let's assume we all in our room assume that we want to talk at the same time. What will happen? Noise. Nobody will hear anybody. But if we just shift the signal of each one of you to a certain band that's not interfering with another person and nobody hears him, then the communication will be effective without any interference. So there are many reasons for why we need modulation, but you can summarize them mainly in 3 points, 3 corner points. 1, to make the signal suitable for transmission over a certain medium. Yes, prepare your signal to be transmitted over a certain medium. For example, your voice signal or music or audio cannot propagate directly through a copper cable, through an optical fiber cable. You understand me? You need, because the bandwidth, the frequency of this cable, the frequency at which this cable allows signals to pass through does not allow the voice signal to pass through. That's why I need to modify my voice signal to a different frequency so that it can pass through and reach my receiver. This is 1, to make the signal suitable for transmission over a certain medium, because the medium bandwidth, the medium frequency is different than the frequency of my voice, for example, or the data. If you want to transmit your voice directly, you will not be able to send it. It will not reach, it will not even propagate through the cable. Second, to be able to communicate over long distances. If you want to reach long distances, your voice power is limited. You cannot just reach 100 kilometers with your voice power. It's limited. To be able to communicate over large distances, you need to shift your signal to a certain carrier frequency that can allow your friend to listen you, hear you, and decode your data and understand what you want to say to him. Third, to serve multiple users at the same time. If multiple users want to talk to each other at the same time in a room, they will interfere with each other. But if you are using your phone, because the modulation technology is embedded inside your phone, everybody is talking with anyone he wants without causing interference to anybody. He has a dedicated direct channel to his friend. No interference with anybody. And that's why we have such a technology. So this is the key reasons why we need modulation. Now let's give specific examples to let you understand these reasons practically. Let's assume the following. Why do we need modulation here? Let's assume we have a communication channel, which is cable, that only operates at a certain frequency range, from let's say 100 mega to 2000 mega. 100 megahertz to 2000 megahertz, and you want to send your voice signal. What's the frequency of your voice signal? 3 kilohertz, up to 3 kilohertz. 3 kilohertz is out of the band of 100 to 20 mega. 3 is out. 100 is here, 100 is here, and let's say 20 is here. And 3 is out of the band. In this case, what will happen? Your medium, your channel, your cable will not let your voice pass through. To avoid this problem, what do? You need modulation in order to shift your signal frequency to a frequency that's within the range of the bandwidth of the cable. Modulation basically translates a signal from its baseband to the operating range of the channel. You have to be within the operating range so that you can transmit and receive your data successfully. In other words, we can say that modulation is used because the same data signals are not always suitable for direct transmission. You have to make some changes to the signal so that you make it suitable to be transmitted over the channel. So, by modulating different signals to different frequency bands, they can be transmitted simultaneously over the same channel. This is a technique that we usually use called the frequency division multiplexing. Again, let's get this example. Assume you want to send your speech signal without modulation. What's the frequency of your speech signal or audio or whatever? Let's assume for this example, let's assume the audio signal, the frequency is 20 hertz. The range of audio is from 20 hertz to 20 kilohertz. Your voice frequency can reach up to 3 kilohertz for males. For females, up to 3.6.4 kilohertz. The frequency of the female is higher than the frequency of the male. For example, if I tell you, close your eyes and tell me whether the one who's speaking, the person who's speaking, male or female, cannot you distinguish? You can. What's the reason? The frequency, your ear can understand that the frequency range, or usually all the females, the frequency is sharper and higher than the frequency of the male. And anything is like this. Each and everything in life has a certain frequency. Your body has a certain frequency. Each and every cell inside your body has a frequency. The table has a frequency. The chair has a frequency. Each and every material and every subject, every object in life propagates a frequency. This frequency resembles and give properties about the material, the living things, the object, anything. So when you start studying frequencies and communication in general and wireless more specifically, you will start to understand the world around you. Tesla, what did Tesla say? He said that if you really want to discover the secrets of the universe, then study electromagnetics, wireless signals, how they propagate, how they go, how they pass. Like for example, we have many signals going through our bodies now exactly at this moment, but you don't see them. Why? How can you see them? Why cannot you see from behind the wall? Why cannot you hear people who are speaking at a frequency higher than 20 kilohertz? Your ear can hear voices or sounds up to 20 kilohertz. Anything above this, you don't hear it. 100 mega, 100 giga, 100 tera giga, you don't hear it. So imagine how many different things are happening in our life and we are oblivious to them. We don't know that they exist. Imagine. The same with our eye. Our eye can see only frequencies that has wavelength of 400 nanometer to 900 nanometer. Anything above this we don't see. That's why we can only see light. Imagine how many different objects, how many different things and living things we don't see that are beyond this spectrum. And this spectrum is extremely narrow. So we are limited. So if we want to tune the communication process and make it suitable to us, we have to do this modulation process so that we put the signals in the suitable range so that we let it propagate, and when we want to see it and read it and understand it, return it back to our spectrum. That's why we need modulation. Shift to this frequency so that I can send it practically, and then when I receive the frequency now, shift back to my range that I can see and hear and understand and feel and smell. That's it. So the speech and the music signal is from 20 Hertz to 20 kilohertz, can only travel for a few distances. This signal, if you speak directly, it can only travel for how many meters? 100 meters, 200 meters, that's the range. To receive the transmitted signal, if you want to just directly communicate with your voice and you want to receive it, the length of an antenna that propagates your voice should be quarter wavelength of the frequency used. What's the frequency here? Let's say the frequency is 20 kilohertz. What's the wavelength in this case? The wavelength of the antenna. If from the equation that says lambda multiplied by frequency equal to the speed of light, then lambda is gonna be equal to c, the speed of light, over the frequency. What's the speed of light? 3 multiplied by 10 to power 8 meter per second. What's the speed? What's the frequency here? The frequency is 20 kilohertz. Divide them over each other. What will be the length, the wavelength? 15 kilometer. The wavelength is gonna be 15 kilometer. Then what's the antenna size? The antenna size is lambda over 4. Lambda over 4, when you divide 15 over 4, you get 3.75 kilometer. If you want to send your voice signal directly and use it for modulation, you need an antenna of length equal to 3.75 kilometer. Now tell me, is this possible? The antenna inside your mobile phone is 5 centimeters, 8 centimeters sometimes. No more than this, so that it's practical. You can put it inside your phone, inside your mobile, inside your laptop, inside your tablet. But imagine without modulation, what kind of problem we will face. We would need to install antennas of length equal to more than 3 kilometer, man. Out of sense, out of practice, something that you cannot even make sense out of. So to avoid this problem, we need modulation. Why we need modulation? Now think with me what will happen when you shift your signal, modulate it, change it to a carrier frequency that's a little bit higher. When you increase the carrier frequency, what will happen to the division? C multiplied by the frequency. When you increase the denominator, what will happen to the value? It will decrease the lambda. So in this case, if you put the value, your phone operates at a frequency equal to 900 megahertz or 1.8 gigahertz. This is the frequency that your phone receives from the tower. If you operate at this frequency, then the wavelength of your antenna will be around 32 centimeter, and divided by 4, it will be 8 centimeter. 8 centimeter is this much. This much, 8 centimeter. This can fit within your phone. Now it's practical, you can use it. So this is one of the key problems related to the practical size of antennas that can only be solved by modulation, only. So in summary, since you understood now why we need modulation and what modulation is, let's repeat the following 3 points. 1. The antenna needed for transmitting signals should have size at least lambda over 4. The information signal is of low frequency, usually. The information signal, your voice, audio, picture, video, all of them, they have very low frequencies. You cannot send them directly over the channel. And therefore, the wavelength is high. If the wavelength is high, you need very large antenna, which is impractical to have an antenna of 3 kilometers. If we need to transmit such a signal directly, the size of the antenna will be very large and impossible to build. Hence, direct transmission of your information, voice, text, video, picture is impossible without modulation. Imagine the importance of this modulation. Each and every day you are using it, but you never ask yourself, how does this happen? What enables this? What enables me? What gives me the power of being able to communicate with people who are far away from me, thousands of kilometers? This is due to a concept called modulation, which is changing the properties of the carrier so that it's suitable to the medium that you want to transmit over. This is the first point, practical size of the antenna. Second, if we transmit the information signals directly, the signals from different transmitter will get mixed up and the information will be lost. As I told you, if you send your signals, you generate a signal and you generate a signal and he generates a signal. All of you send together without assigning a specific frequency to each person. All of you will be on top of each other talking on the same frequency, and you will create interference, and therefore nobody will understand anybody and the communication will not be effective. So modulation allows you to shift each user signal to a certain band, a certain frequency that's not interfering with the other frequency, and therefore each one gets his data successfully. When a wave has a larger frequency, the energy also associated with it will also be large. Another reason we try to build better modulation schemes in order to improve the efficiency of using the channel. I told you once that the spectrum the companies buy from governments is very expensive. They pay millions of dollars for it, and in order to solve this problem, they try to come up with techniques that can utilize the spectrum in a very efficient manner. And this example on the right hand side explains to you how to do the calculation and make sense of the practical requirements. So now let's go to the classification of modulation schemes. I always, whenever I just told you, whenever somebody mentions modulation, link it with the word changing. Changing what? Properties of the carrier signal. What are the properties? Amplitude, frequency, and phase. According to the incoming information, you make a rule, mapping rule. If 0 comes, let the amplitude of the carrier 10. If 1 comes, let the amplitude 0. You can put any rule you want. Don't stick with the rule that the text box shows you or the teacher tells you. There is no rule for modulation. Modulation can work with any rule you want as long as you abide by the main principles. As long as you are following the main principle of modulation, you can change anything you want and still get your message go through successfully. For example, what I mean is the following. Let's return back to this example. Now I can see that when 1 comes, the amplitude here remains the same. And when 0 comes, the amplitude suppressed. Now one of you might ask, cannot I come up with a new scheme, with a new rule, with a new mapping rule, where I can say, when 1 comes, I want my carrier signal to be 0, and when 0 comes, I want my amplitude to be 10. Is this wrong? No, it's correct. It's fine. You can make the rule you want. Still, you will be able to propagate your signal successfully. But you need to inform the receiver, let him know that I use this rule, please use this rule at your side so that they understand each other. Let me put it this way. If you want to send a secret message to your friend and you don't want anybody to understand it, and you know that this message will go through many people, I will hand it to Murat, Murat will hand it to Batuhan, Batuhan will hand it to another, and the message is written. And the condition is this, the message should be only understood by Murat and Batuhan, let's say. So what Murat will do, Murat is very clever, he will say, okay, I will write, meet you tomorrow at 9 a.m. Murat will say, I will change each and every letter to another letter from a different language, so that when the letter passes by another student or another person, he will not understand what this language is or what's the meaning of these letters. Yes? So Murad, to let his friend understand how to decode the message, Murad has to share the mapping table with him. Isn't it? If you don't share, how would he know? This is the secret. Just like the way you make sure your message can reach your friends securely, we have modulation, we have something called mapping process. This mapping process should be shared between the transmitter and receiver. Both of them should understand it. Okay, this is the simple definition of mapping. When I mentioned here mapping in my definition via mapping, this is what it means, mapping. So let's go to the different types of modulation. We have modulation. We have analog modulation, analog and digital. Modulation has like analog and digital. Always you see digital modulation, analog modulation, and you get confused. Let me explain this to you simply so that you don't forget it. What's the meaning of analog? Analog means something continuous, has infinity number of points. No matter what you go deep, you still find points. What's the meaning of digital? You have discrete finite number of values. Like between 0 and 1, I want only 4 values. You can take quarter, half, 3/4, and 1. That's it. But if you are analog, there are infinity number of numbers between 0 and 1. If you are analog, if you are allowed to take any value you want. I can take 0.0, 0.01, 0.0010, 0.00, infinity. This is analog, continuous. But digital, only certain values you are allowed to take. That's digital. So let's now, from this understanding, let's classify modulation schemes. We have analog carrier and digital carrier. If we use analog carrier and analog data, we have what we have here. We can have amplitude modulation, frequency modulation, phase modulation. Those are all analog modulation. If we have analog carrier and digital data, then we will have amplitude shift keying, frequency shift keying, phase shift keying, and QAM, and many others as well. But those we will call them digital modulation schemes. Why? Because the data is digital. And here we call them analog. Why? Because the data is analog. You like direct voice message, direct audio, direct picture, whatever. Now, also we have digital carriers. In this case, we might have analog data like pulse amplitude modulation, pulse width modulation, pulse position modulation. And those we call them also analog modulation schemes because they use analog data. And PCM, we call it digital because the carrier is digital and the data is digital. So here we can also, modulation schemes can be classified analog and digital. Analog modulation example, amplitude, frequency, phase. Digital modulation, amplitude shift keying, frequency shift keying, phase shift keying. The only difference is in the message. Here the message is analog, here the message is digital. What I mean by digital, it's 0 and 1s, 0, 1, 0, 1, 1, 0, and you modulate it. Also, in the course of Introduction to Telecommunication, you will be seeing videos, recorded videos, explaining each one of these modulation schemes, analog modulation schemes. Examples of analog modulation scheme: amplitude modulation, digital sideband, suppressed carrier. Second, amplitude modulation, not digital here. Amplitude modulation, double sideband. And CS means suppressed carrier, without carrier means. And amplitude modulation, double sideband with carrier. WC means with carrier. And also single sideband with carrier and suppressed carrier. With carrier and without carrier. Suppressed carriers means without carrier. With carrier means WC. And then after you watch all the videos related to these types of modulation, you will deeply understand how to do them mathematically, visualization, and then you will move on to the analog angle modulation, which is consisting of 2 types, frequency and phase. And this is also another classification that we talked about. But now I will draw your attention to 2 types of classification. Sometimes we classify our methods into modulation schemes into constant envelope modulation scheme and non-constant envelope. If in the test I tell you, give me example of constant envelope modulation or non-constant envelope modulation. What does this mean? Constant envelope means the amplitude of the carrier doesn't change. In general, the amplitude remains the same. It doesn't change significantly. But non-constant envelope, the amplitude keeps changing and fluctuating. Example, give me example of constant envelope modulation scheme that has constant envelope. The amplitude of the carrier doesn't change frequently. You can say frequency shift keying, phase shift keying. Give me example of non-constant envelope, amplitude shift keying, QAM, and so on. Now, why it's important? Which one is better, constant or non-constant? Which one is better, constant envelope or non-constant envelope? Practically, it's better to have constant envelope modulation schemes. Why? Because constant envelope, it will be good for the power amplifier. It will not reach the saturation point. For example, if your modulation schemes keeps fluctuating up and down, the peak of your modulation scheme can reach the saturation point of the power amplifier, and the power amplifier will cut it like a diode. And if it cuts it, it cuts information, it causes interference, and you lose data. I don't want this to happen. That's why we usually prefer constant envelope. Another classification for modulation scheme is coherent and non-coherent. What's coherent? Coherent means that I need the information phase of the carrier. Non-coherent, it means I don't need the information phase of the carrier. Which one is easier to demodulate? Non-coherent. Non-coherent is easier to demodulate because I don't need to synchronize between the phases. I can demodulate my data directly. Give me example on coherent. You can say amplitude shift keying, frequency shift keying, phase shift keying. Coherent, basically, the most common one is amplitude shift keying and phase shift keying. Amplitude shift keying, phase shift keying are the most common coherent schemes. Non-coherent, the most common scheme of non-coherent, amplitude shift keying and frequency shift keying or differential phase shift keying. So these are the differences. So coherent gives you better performance, but very difficult detection process. Non-coherent, easy to detect, but the performance is very low. So with this, I hope we explained what modulation is and why we need it, and examples on it, and some properties and some key advantages and disadvantages, and what key details we look forward when we build or come up with a new modulation scheme. Thank you, everyone. Take care, stay blessed.